I'm excited to introduce a new tool that is Procedural Thread Simulator. With this, you can simulate any kind of thread like iron chain, bead chain, cables, pipes, ropes, spirals, wires, etc. And it is 100% procedural and made with the geometry nodes. It comes with this 11 presets that you can easily add into your scene. Just click and drag. Now you have this bead chain in your project. Similarly, you can add different one like this connection lines. You can create the connection lines between these objects. However, if you want to build a custom thread type for your project, you can do that with the thread solver nodes and the utility nodes. These are the general utility nodes. They are compatible with the thread solver as well as for any curve. So with this, you can build the simulated thread type or a static thread type. And it also comes with the different materials that you can use. In this video, I'll show you from where you can download this preset, how to use this as assets and settings of the thread solver and the utility nodes, and also the 4 project files that come with this preset. So let's get started. You can get this tool from the Blender Market, from my Gumroad page or from my Patreon page. So from there you can get these 2 zip files. One is thread and another is the project files. So let's first talk about this. Inside this, it contains these 3 files for different Blender versions. So let's open this one. So it contains the asset file, documentation and the main blend file for the thread. Okay, you can read this documentation. It has detailed information about the settings of this thread solver and utility nodes and how to combine these different nodes and how to use them. Okay, so now let's use this as asset. So we need to assign this folder as a library in Blender 4.1. Go to the preference and in the file path here, we need to assign that folder as asset library. See, and let's add this as asset library. And if you go to the asset browser, inside this KS tool, you have this thread category. It contains all these nodes. You have this thread object, thread solver, all these different presets of thread types, then utility nodes and the material. So let's talk about this thread object. Thread object contains all the nodes, including the utility nodes and all these thread types. It is kind of main setup that allows you to build your own custom thread type for your project. And this is the thread solver node, which is the main node to solve the thread simulation. So let's add this inside this project. So we have this, and let's go to the geometry nodes. So it contains all these nodes, the utility nodes, main solver node, and all these different thread types. Let's talk about the settings of this thread solver node. I'll briefly go through all the settings, but you can find the in-depth explanation of the settings in the documentation. So this is a thread object and it has this modifier. In the modifier panel, you can specify the curve, the object to chop this thread, and also collection for the collision. Okay, we have the first setting that is for the curve. So here you can input any curve. It can be based on the geometry nodes or the object. And then you need to define the number of points based on the count or the length and also the radius of the points. Let me connect this bead chain, and if we go to the first frame, so the ideal condition for this length and radius is that the radius should be half of the length step. Okay, so this is the ideal condition, and if I run this, see it is start with stable simulation. However, if I make this slightly less than the double of this radius, then it's going to push the curve point so that it satisfies this radius condition. Okay, if you make this slightly larger than this double of this radius, then it's going to mimic like a stretched string. And you can also use this count if you need a specific number of points in your thread. Then we have the simulation settings. So first you can define the start and end frame for the simulation. and then this delta time. You can use this delta time, which is basically based on the this frame rate of your project, or you can use time step, which is a custom time step for this solver, and it allow you to speed up and slow down the simulation. After that, we have the substeps. Substeps basically the quality step of the simulation. If I make this, let's say 3, then it's going to create a really stretchable type thread, and you can also see that the simulation is not very stable. So use this step around 15 to 20 or higher number to make your simulation stable. Then we have the stiffness parameters. You have the tension, bending, and hardness. The tension is basically force that act along the length of the thread. Try to preserve the length of the thread. If you make it small, the dynamics looks like a stretchable type thread. If you make it fun, then it's going to really try to preserve the length of the thread. Then you have the bending. Bending parameter is allowed how much a thread can bend. If I make this 0.5, then it's going to make this thread really straightened and stiff type. And this is really useful to create like PVC pipe type threads. And after that, you have the hardness. So hardness is basically a resistance to the local deformation. Let me go to the first frame. See, we have these local deformations, and if you want to smooth them, you can increase this hardness. Then it's going to create this really nice smooth motion or the dynamics of this thread. And it's also to create something like a very big and heavy rope that don't have that much deformations. Then we have the dynamic settings. So dynamic settings contain the damp factor, force factor, and the forces. Okay. So damp factor is basically allow you to damp the motion of the thread. Then we have the force factor, which is allowed to play with the forces where it is dominating or not. And here you can add the multiple forces. By default, it is set for the gravity. However, you can add multiple forces, like we can add the turbulence force based on this noise texture, and we can add this gravity. So this is going to be the gravity, and this is going to be our turbulence force. And one thing you may notice, this is the force factor. It is not the strength of the force. So here you can define the strength of the force independently. Okay. See, we have the gravity, and this is simulating like a wind is blowing in this direction. So you can create this kind of effect. And after that, we have really important settings, that is the pin setting. So by default, this thread is pinned to its parent curve from the start and end points. So if I move this, you can notice that it is following this, the motion of the parent curve. See, it is moving with this. Okay. Here there are three types for the pinning: initial, current, and custom. In the initial, it's going to pin the thread to its parent curve, this base input curve. And in the current, it's going to pin the thread to its current state. So let me make this one. See, if I make this, it get pinned here. Okay. It's going to pin the thread to its current state. It's like a relative pinning. And then you have the custom. So here you can define the custom position to pin the thread points. Okay, it can be to attach the thread to the different objects, or to attach the thread to a different thread. Okay, you have two selections. One is this one and another is this one. So this selection is a dynamic selection. It is relative to the thread. Means if you chop the thread, then this selection will change. Okay, and you can do this something like you can add the random selection here. By the way, most of these settings are based on the fields. You can use different fields to change them or influence them. So now we have this random selection. Let me show you the selection. we have this kind of selection. See, it pin the thread from there. If I make this around 0.2, we have this kind of pinning. And that you can also do with this start and end settings. And this is the second selection, and it is relative to the input curve. Okay, so you can pin the thread from the start side or from the end side, and you can also change the selection region. So by default it is set to a 1 point. If I make this around 5 here and also this 5, then it's going to pin the 5 points, and you can see that we have pinned these 5 points. Okay, and with this vector you can release this pin. See, because we are in the initial state, so if we release this pin, and then we can also snap that back to the initial position. If the thread is really far from the base curve, then re-pinning this thread may make this simulation unstable. Let me show you this. See, then we have break setting, so that allow you to break the thread based on this selection and distance threshold. Okay, let's first enable this. So by default it is set to slightly higher than twice of this radius. If I run the simulation, see, it's got broken because at the start we have a really strong motion. That's why it get broken. So let's make this around 0.65. See, it is stable. And now if I animate the parent curve, then that motion is going to break this thread. See, it breaks from these points. Okay, so there is another important parameter is the selection. So this break setting comes with the selection. You can define the selection from where this thread break. Okay, and you can use this node, which is thread selection node, or you can use your own custom selection from where you want to break the thread. So let's visualize this. Let me hide the original curve. So you can generate the selection for all the curves, or you can use this for a particular spline, and you can get the selection based on the index, which is like this, or you can use the end selection. In the index case, you can also spread this selection from that index. Another thing is that you can exclude the cyclic splines from this selection. Okay, use 20 and 5 spread. So we want to break the thread from this region, so let's connect that to this. And now if we go to the first frame, let's clear this rotation. Now if I move this parent curve, then it will break from that selection. We can visualize that, I think so. Yes, so it is pinned. Now let's see. See, it breaks from these points. So with this you have a full artistic control from where you want to break the thread. Sometimes it is really important to break the thread from a particular point to tell the story. Next we have the chop settings. So you can use the mesh object to chop this thread. It can be open or closed. If it is closed, you can enable this option, check inside, and here you can define the probability whether the object or geometry is going to chop the thread or not, and this is the threshold distance from the chop geometry. So let's add the cube scale on the x-axis, scale down something like that, move it to the above, and now we need to select this chop object here and enable this option. Okay, and we can also use the bead types, and let's see. See, with this you can chop the thread, and we can do something like this. If we go to the edit mode, we can create a multiple copies, and now it's going to chop from this. So you can create multiple slices. It's going to work for all these things. ropes, spirals, pipes, PVC pipes, and cables. Okay. In this way, you can chop the thread. However, if I make this around 0.5 and slightly change this, the seed, so it may not get chopped from different portion. Yeah, it can. Let me increase this down. See, it's not get chopped from the center. It is only get chopped from the end side. In this way, you can play with this probability and the seed. Next, we have the self collision. By default, it is enabled. With this option, the thread going to collide with itself and also with different threads. So we have this thread. Now let's add more. Duplicate this one, rotate along the z-axis, something like that. So we have these two threads, and if we run the simulation, see, they are colliding here. See, and you can also add the friction, means when they are colliding, they're going to affect their motion. So this is really important when these threads are lying onto a plane or ground, and you pull one of the thread, then the rest of the thread going to be dragged along. So you can achieve that with this friction. And another setting is the use weight. It is really useful when you use the random radius of 0.02 to 0.03. We have this different radii, and for this case you can enable this use weight option, and it's going to make this self collision stable. Okay, otherwise the collision may not be stable and smooth. Okay, so this is mainly useful when you have this random radius per point. Next, we have the object collision. So for this, let's add the external object. Then we need to put this in a new collection called collision and select that collection here. So this is the collision collection option, which is basically this, and then enable this setting. See, it is colliding with this cube, and if I make it now we have this. So let's see. Now this thread is colliding. Let me make. Now we have this. So let me first unpin the start and end. And now I'll show you this setting, bounce and friction. So if we run this, see how this thread get bounced from the surface. And if I make this really low, around 0.2, now it has a less bounce. Okay, you can also play with this friction. If I make it higher, around point, let's try this 0.2, then it's going to damp the motion. See, this thread get stuck to this surface. Very low, then you can increase this. As I said, these are the field-based settings, so you can define different regions on this surface to have different bounce or different friction. Okay, next we have the custom edge. This is the special settings that allow you to add a long edge inside the thread based on this index selection. So it is get added here. You can access the data of this long edge using this node. So it will give you that edge and also the tangent of that edge. You can hang something like painting or logo or something with this. Here you can define the length of this edge, and also you can use a different hardness weight as compared to this. Okay, so these are the settings of the thread solver node. So let's talk about the utility nodes. First is the thread connection node that generates the connection curves between two mesh surfaces, and it is used in the connection thread type. So let me go to the geometry nodes. See here, it generates the curves. You can add more number of curves, and you can also align them along the normal of the surface. You can use them as static connections, or you can also simulate them with the thread solver node. Okay. Next, we have the thread selection, which is already I have explained. Next, we have the thread info node that provides the different attributes of the thread, so that you can utilize to create a different thread types and thread profiles. And it is also available in the material to create different type of materials for the thread. Next is the thread custom edge, which basically provide the custom edge geometry based on these settings. And next is the thread hanger. Let me go to the asset browser. So we have this thread hanger preset. So here I have set up this thread hanger object node. You can instance any object that you want to hang on this custom edge, and you can change their local rotation, and you can also add these joints, and you can change their radius and subdivisions, and here define the material for this. Okay, so this is the thread hanger object node, and another is the thread instancer. So it allow you to instance onto the thread, or you can also use any curve. So we have this. Now let's add cone. So you can create a chain of cones. You can also change their location of instance. You can instance them onto the points or on the edges. And here you can also add a selection where you want to instance them onto the thread. You can pick different instances. You can change their local rotation. And here you can also add a custom scale. So by default, we are using the scale based on the radius. Okay. After that, we have these different thread types. So you can input the curve or the thread, and you can change different parameters like custom radius. You can use even custom instance. Let's add the cube here. You can instance the cube, align them according to the tangent of the curve. Similarly, you have the chains. So you can change the radius, width, and height of these chain links. Then you have the rope. You can change different parameters of the rope. You can also twist the geometry. Then you have the spiral. You can add multiple threads of the spiral. Here is the base count for that. And then you can change the spiral radius. You have very thin spiral wire type thread, and here you can change the frequency, low frequency, high frequency, change the phase offset. So with this you can also generate a kind of a rope that has twisted threads. Let me make 3 of them and slightly increase the radius. See, we have this kind of rope. So these are the general profiles. You can read more about them in the documentation. So this is the pipe or rubber flexible pipe. Can play with the settings like this radius vector and this minimum radius, maximum radius, and the frequency. And also you can offset the phase. Even you can use a custom profile. Let me add the star and add custom profile. Now you have this star based curve. Let me make this vector 0. See, you have this kind of pipe. After that, we have the PVC pipe. So here you can change the thickness of this PVC pipe and also the resolution. There is also option for different material for the caps and the surface. And the last is the cable. So you can change the base subdivisions, and here you can change the number of these wires, 20 or 50 or higher. Then you can play with this radius. I'll show you why it is important. And here again you can change the frequency, add more twist to these wires, and also change the thickness of these white wires. And you have separate setting for the core. You can even hide the core. And if I add the random node here, so now you have these multiple wires. Let me change the phase and also decrease the frequency, maybe around 20. On this, maybe around 90. Something like that. Now you have this multiple wires, and here we can add the wire material. See, now you have these kind of wires. So there are many ways you can play with this. You can even get these wires curves. You can instance them something onto these wires to create those Chinese lights. So these are the profile settings. I recommend you read more about these settings from the documentation. If you have any query, you can ask me on my Discord channel. So these are the settings of the thread solver and the profiles. Now let's talk about the 4 project files that come with this thread preset. Here we have the project files. We have these 4 files. 2 project files for Blender 4.1 and 2 project files for Blender 4.2. Let's open the first project file, this job. We have this rope. So I have added these rings for the collision and also this cube for the collision. And I'm using this cube also as a chop object. So it is important to add the chop object also in the collision collection, because when it is going to pass through this thread, it should collide with the thread as well. Okay, so these are the settings I used here. These are the curve setting and these are the stiffness setting. In the chop setting, I just added this cube to chop this thread, and this is the setting for the collision. So when we run this, it's going to collide with this. Okay, so let me first bake this. So we have this, and if we run this, see, it is cutting through and also colliding with the rope. Next is the roll project file. So in this file, I basically roll these chains onto this object. So this object has animation. Let me hide the chains. So it is rotating like this. Okay, I have also parent this curve to this object. See, it is rotating with that. Next is I used this object as a collision object in the thread. Let me select this. So this cylinder as the collision object, and in the pin setting, I'm only pinning the start end or this end of the thread to the base curve. Okay, so this base curve. In this way, we can wind these chains to this cylinder. See? Okay, this is how you can wind any these thread to a different objects. Next is the break project file. We have this. Let me hide these objects. So let's also hide these handles. First, I have created these connection between these two objects using this node. So these are the connection curves. Then I added them to the solver. These are the settings for these curves. In the pinning, I have pinned it is start or end, and use 3 for the start size and end size. Basically, you want to create the effect like something is holding these threads from the start side and also from the end side. Okay, so I'm using this selection to break the thread from this point. Okay, so we can see that as it gets stretched, it gets breaked from that point. Okay, and this is the threshold for the breaking, and these are the settings for the collisions. And for the collisions, I'm using these handles. So thread going to collide with these handles. See, probably you can see that. See, it is colliding with the handles. After that, I used the rope thread type and added this material, rubber material, to create this rubber strings. Okay, so in this way you can set up the break conditions. And the last project file is the noodles. These are the base curves I used for the noodles. So we are using this for the noodles. These are the settings, and I'm using this pen. It is low resolution version for the collision. Okay, we used here, and I'm using high resolution for the rendering because we have a really non-ideal condition. So at the start we're going to have really violent simulation, but as it get calmed down after 50 frames, we can release this pinning. Okay, so that's why I have added this condition. When it is done, then we're going to have the noodles. Now see, at the start we have really violent simulation, so that's why I added this pinning, and after the 50 frames I released that pin. And for the profile, I use this row profile and with this noodle material to have these noodles. And I also use a custom radius instead of the main radius of the threads, because just to avoid any overlapping of these noodles. If you don't want to use this, you can increase this number of sub steps. In this case, I have also added a higher friction or self friction as well as this surface friction. So this is it about this thread preset and all these nodes and project files. If you have any kind of doubt, you can ask me on my Discord channel and I help you out. I have provided the link in the description from where you can get this tool. So thank you for watching. See you in the next video. Happy noding. Bye.